So we'll talk about something that people usually don't talk about all that much. But it's very important if you want to design your own vacuum tube amplifier or vacuum tube power supply and all these other fun things, all sort of vacuum tube gear. This is to a lesser extent also true for solid state gear, although the precautions you take for the high voltage here are much less important if you only got 5 volts. So, as you guessed from the title of the video, it's about fusing in vacuum tube circuits, and especially in the high voltage section. We'll talk about the heater section or the filament section later, but it's mostly going to be about the high voltage section. Also, what I'm going to say here is true for Central European countries that have a 230 volt supply and that don't use ring mains. If you live in the UK, then you have to do things a little bit different. First of all, you got to have a fuse in your plug and all these other sort of things. I'll cover that in detail a bit later. Yeah, so I'll start with, this is my just generic power supply. I have the mains coming in here. I've got a great big chunky transformer here. I've got a bridge rectifier B. This is drawn as solid state, but it could also be a vacuum tube rectifier, bridge rectifier. Then also I've got my capacitor here, and I've got this going off to whatever on the ground over here. I've got no central tab because most of the transformers I have here don't have central tabs. It used to be very common to have center tabs here, and I'll talk about that in just a minute, but we'll just do this first of all. This is basically the simplest circuit. What you should definitely have, this is a really a must-have, or else you'll burn your house down, is have a fuse in your primary here, fuse the primary, not in the primary, but fuse the lead to the primary. It doesn't matter if it's here or here, because our plugs are non-keyed anyway. It changes if you plug it in the wrong way, then it will be all reversed. So, have a fuse here. This will trip when this winding here fails, or to a lesser extent if something fails here and sort of couples through. This is very important because else you'll be totally reliant on it's usually a 16 amp breaker, and if you've got 16 amps flowing through here, you'll make a lot of smoke and it will be quite dangerous. So fuse this appropriately. If you've got the transformer like this here that I use for something experimental, this is a Telefunken radio transformer. It has 2 fuses already. Those are usually, with those radio type transformers, they're built into the voltage selector here. That you get this with the transformer. The other fuse is here, and it has 2 fuses because one of them is for the 110 volt setting, and I think also for the 125. And the other one is for the 240 and 220, and I think also for the 150. But I'm not exactly sure how this is wired. The thing is, it tells you which fuse to put where. The lower value one is the one for the 220, 240. The higher value one is the one that's used for the 110. Replace them accordingly, and you'll be fine. They use glass fuses here. All old equipment did. If you've got if you live in a Central European country and you've got a 16 amp breaker, if it has 20 amps of, it can break 20 amps, then yeah, you should be fine, because if there's something over 20 amps, your breaker downstream will trip anyway. But yeah, this uses a 400 milliamp fuse for the 230. And yeah, I had this fail once when I actually shorted this out on purpose just to check it, to see if this actually works. And yeah, it worked fine. It did break the primary side. I had no tripping from my wall breaker. Yeah, so have a primary side fuse. Very important. Whenever you're designing any kind of thing, even if it's solid state, have this fused. Just in case the winding fails. So, secondary side fusing on the high voltage lines. For a circuit like this, it's actually kind of easy. You should put your fuse here or here. Don't put it here, as some people do, and don't put it here, which nobody does. If you put the fuse here, big fuse, you're protected from all kinds of faults. And also your secondary side is protected, which is nice, because transformers are expensive these days. If you've got a short down the line somewhere here, you will trip this fuse. Simple. If you put it here, you'd also trip this fuse. But there's a disadvantage to putting it here. If this capacitor here fails, you'll also be just fine. I just need to switch my pointing pen. This one is better. If your capacitor fails, yeah, you'll be fine. If you put it here and one of your rectifier diodes fails, you're in for a nasty surprise. You will have nothing to protect you from current flowing through here, or through here if something goes wrong here. If you've got vacuum tubes to rectify your supply, you'll probably be fine, because usually nothing goes wrong with those. But why wouldn't you put the fuse here? It's no inconvenience at all, and it's just much safer. Yeah, just put your secondary side fuse here. If something goes really wrong, you'll probably blow both of those simultaneously, but usually, yeah. If you do it properly, then if a fault occurs down here, this should actually break first. This should also be appropriately rated for your high voltage supply current, which by default has to be less than this, because you're also having the, let me draw that in here. You'll also have the heater winding, most likely, to go off from here, so the power that goes in here is larger. Also, your voltage here will usually be a bit higher, so this should have a lower current rating in 90% of cases. If you're not doing something like having 240 in and getting 100 volts out here for some sort of weirdo tube, then things are different. But yeah, this is the general case. Yeah, that's, I think, most of the things that you should say about fusing in the high voltage section. Heaters, you can definitely fuse. If you've got a straight AC alternating current filament supply, usually nothing goes wrong, except if you or the user just shorts those out by bumping it or something, or just inserting a vacuum tube wrongly, something like that. So usually those are unfused. Actually, in older gear, usually they also admit that fuse. Yeah, it's all up to you if you fuse it. It's definitely safer if you do put a fuse in here, like this. That then goes off to the filaments, like so. Yeah, but strictly speaking, this isn't generally necessary. If something goes really wrong here, you'll probably burn out this winding. And if it goes wrong badly enough, maybe you'll trip this fuse. But yeah, this will usually burn out. It could set things alight, you don't know. If you have something like this, it is fairly unlikely. If you've got a rectifier in here, and you're using DC filament voltage, I strongly advise you use a fuse here. So if you have something that looks remotely like this, I forgot to draw the other side of the transformer, which is, yeah, fused. Something could go wrong with your bridge rectifier, or this capacitor could short. Filaments usually don't short. They were basically, I think, engineered to fail open, which is not hard, given that they have the tendency to fail open. But since gear was usually unfused in the old days, I think those were... I've never seen a filament fail short in my entire life. So yeah, if you use a bridge rectifier and some sort of arrangement that has DC, use a fuse here. You have to rate this appropriately, and you have to rate it for the for the cold start current that those filaments draw. So when they're cold, they'll have a third or quarter of the resistance that they have when they're hot. So a lot more current will flow through here. You have to either use a very slow blow fuse. They are meant for things like that. Or you use one of, well, just the appropriate rating. Check what your nominal current through here is, check what your inrush current is, check what the current capacity of your transformer is. If your transformer can supply 5 amps nominally, and your filaments take 2 amps nominally, I'd fuse it so that if this shorts, the fuse definitely blows. I'd maybe use a 4 or 5 amp fuse. If this shorts, if it's normally a 5 amp transformer, it will definitely have a higher short circuit current than 5 amps. It will blow the fuse wide open. And yeah, if this gets uncomfortable above 5 amps, you should protect it from getting above 5 amps by usage of a fuse. And I think that's just about all that can be said about, I bet there can be said more, but this is sort of an intro to fusing in those kind of circuits. So if you're doing it properly and right, you'll have 3 fuses, 1 in the filament supply, 1 in the primary, and 1 in the secondary that I showed on the other page. And then you should be safe. You should definitely be safe. One word about fuses for heater or filament windings. You could use something like this, which is not a very fast one though, like a standard ceramic type fuse. You could also use a glass one, but I don't advise it in this kind of situation because the current, short circuit current here might be especially if you're using large transmission type tubes where you have filament supply of 20 amps, you will not find a little glass fuse that can break short circuit currents of 100 amps or 50 amps. So use something like a big high rupture capacity fuse. And yeah, for filaments like this, you should usually use a slow blow fuse. While here, you can use a slightly faster one, and in the high voltage supply, you can also use a faster one, because the inrush is not so massive. The inrush is most likely just topping up this capacitor here. Once you start it, it will quickly fill up that capacitor, and then you'll have to wait till the tubes warm up, till you draw any significant sort of current. With this, you'll fill up this capacitor, and then you'll have this low resistance pulling on it for, 10 seconds or so. Maybe the initial warm-up is maybe 1 or 2 seconds, where you draw a lot of current, and then it sort of tapers off like this. Because the temperature starts rising, and yeah, filaments have high resistance when they're hot and low resistance when they're cold. What do you do with your ever so popular center tap transformer? You have a fuse in your primary, but you have 2 lines here that are sort of equal, and you've got one here. In the olden days, it was actually somewhat common to put a fuse here, which is not a good idea, because if your diodes here fail, you'll have a full return path, full short circuit, and this fuse will probably protect you, but it's better to be on the safe side. So the only thing you can do is you'd have to put a fuse here, and to protect against this failing, discharging through here, back here, and blowing up this side of the circuit, you have to put another fuse here. You cannot do it if you don't have 2 fuses. So if you put it here, this path will be unprotected. If you put it here, this sort of path will be unprotected. If you put it, well, it's just the inverse if you put it up here, but yeah, the only thing you can do is put 2 fuses here. Also, then put it here. You think you can save up on 1 fuse? No, but yeah, same situation as if you put it here. If this fails, you're done for.